Good afternoon, everybody. The title of my talk is Crack Path Theory and Application in Phase Field Fracture Context. This report will be presented on behalf of myself and my colleagues, PhD students Dmitry Kosov and Ruslan Khamidullin. Outline of my talk is crack path at macro scale. Next is the phase field fracture implementation. Third part is the crack path at mesoscale, and finally will be short concluding remarks. The first part of my presentation is devoted to classical approach of fracture mechanics at macro scale. This part includes the vector method of crack path prediction, crack growth direction criteria, definition, fracture process zone size determination, and finally will be experimental results on measurements with digital image correlation. I would like to start this part of my presentation with a question. What is that crack path or crack trajectory? In my opinion, that is a relationship between crack deviation angle and increment of crack length in this direction, which depends on configuration of cracked body, loading conditions, and of course, material properties. So the governing parameters of crack path, in my opinion, is the crack growth angle and some characteristic distance, which may be meaning of fracture process zone size. In order to represent experimental data or prediction of crack path is more reliable and simple is the vector method, which is based on the relationship between crack tip position, previous crack tip positions, and subsequent crack tip position. And this crack path includes crack deviation angle and increment of crack length. In general case of 3D cracked body, for instance, with semi-elliptical incline crack, we need to determine two crack deviation angle. One of them is in plane, another one is out of plane crack deviation angle. These angles changed along curvilinear crack front in general case. So I'm briefly showed the most popular in mixed mode fracture mechanics crack deviation criteria. That is the maximum tangential stress and the energy density criteria, which both are introduced by Professor C. In general case of 3D cracked body, it should be mentioned the criterion of Chang, which accounting for all three modes and all three stress intensity factors. And generalization of this criterion given by this equation, which accounting for elastic plastic properties of the materials. This figure shows the behavior of crack deviation angle along curvilinear crack path for material different properties. And next figure shows the relation between initial incline crack and crack deviation angle for different biaxial loading condition for the different properties of the structural materials. Increment of crack length may have a meaning of fracture process zone size, which is addressed to dominant fracture mechanism, for instance, the cohesive or coalescent one. And this size of fracture process zone depends on crack tip singularity. For instance, elastic crack tip singularity, plastic, classical Hutchinson resin grain rise solutions, and modern theory of gradient strain plasticity theory. The size of fracture process zone, for instance, under non-linear deformation under life cycle fatigue, leads to the equation for crack growth rate prediction, which accounting for size of fracture process zone. And now I will show you our experimental results, which was performed on compact tension shear specimens with inclined curvilinear crack. You see the plastic zone changing under cyclic loading conditions. To the in this figure, you can see our test setup, which includes three-coil hydraulic test machine and micro stereo sensor system with high resolution. It should be noted that this counter of plastic zone is good agreement with the form and size plastic zone obtained on the basis of strain gradient plasticity. And now I move to the second part of my presentation, which is devoted to crack path analysis with a standpoint point of fracture field fracture. In this section, I will show the short introduction to this method and several examples of numerical implementation, which is mode 1 and mixed mode fracture, biaxial loading conditions, surface flow behavior, and one example of practical application. As you know, the theory of theoretical basis of phase field fracture method is the Griffith's balance energy and balance between crack driving and crack resistant force. Modern formulation of phase field fracture includes two new additional variables, that is phase field damage parameter and length scale that governs the width of diffuse crack. One of the basic parameters of phase field fracture is the strain energy density, and the value of total strain energy density governs the crack deviation angle and crack path. In our study, we employed elastic and plastic part of this total strain energy density through the several corresponding equations. And in order to finite element implementation of phase field fracture, it is necessary to arrange components of stiff matrix and a load vector according to this equation. This equation includes governing parameters of phase field approach, that is a stress degradation function, critical energy release rate, that is the fracture toughness or properties of the materials, phase field damage parameter, and length scale factors. And now I move to our numerical examples. And first of them is the well-known compact tension specimen. This type of specimen is most popular in experimental fracture mechanics. In this figure, you can see the relationship between force and displacement for elastic and elastic plastic solutions. This video shows the crack path in terms of phase field damage parameter. Next example is addressed to compact tension shear specimens, which is subjected to initial pure mode 2 or pure shear mode loading conditions. This figure shows our experimental results for middle strength ductile steels and corresponding phase field pattern. And another example is addressed to high strength steels. You can see that in the case of ductile steel, we have got two branching cracks, but for the same loading conditions and for the same boundary conditions, we have got at high strength steels only one kinking crack. Based on these results, it can be concluded that crack path and according phase field fracture pattern depends on plastic properties of the materials. Next example shows the behavior initial semi-elliptical surface crack in a three-dimensional plate under different biaxial loading conditions. You can see in this video how initial surface crack transform from surface to three thickness cracks, and this behavior depends on the loading biaxiality. For instance, under equibiaxial tension, first surface crack grows in the width direction, but in the case of equibiaxial tension compression, surface crack grows first of all towards the thickness direction. Next figure shows the behavior of surface crack. In this video, you can see the stage of interaction, coalescence, and further growth crack with common front. And last example in this section is maybe a structural integrity assessment of turbine, power engineering turbine disc damaged in operation by corner crack in the area of rivet, disc, and blade attachment. In this video, you can see the crack path or phase field fracture pattern in the lug of this turbine disc. And the third part of my presentation is the crack path at mesoscale. This part includes the phase field fracture observation by electron microscopy, dominant mechanism determination and modeling, fetixtration spacing measurements along crack path, and measurements of oxygen distribution by energy dispersive X-ray spectrometry. And now I would like to show the real conformation of diffusive crack model. You see, that is a primary crack and additional small cracks. It should be noted that the size of these small cracks decrease with increase of distance from primary crack. And next figure shows the same picture. Primary crack, and additional crack, primary crack, additional phase field crack, primary crack, and area of additional phase field crack. So, in order to modeling and consideration of material behavior at mesoscale, we need to take into account a granular structure of the material. By employing Voronoi tessellation method and specifying different properties for grain boundary and grain, we are able to model intergranular dominant fracture mechanism and transgranular fracture mechanism. In this video, you can see the crack pass along a grain boundary in terms of phase field fracture damage parameter. Consideration of mesoscale material behavior used a quantitative parameter that is fatigue striation spacing under cyclic loading condition. This figure shows the morphology of fracture surfaces and comparison of fatigue striation specimen as a function of crack length for pure mode 1 and mixed mode loading conditions for steel, aluminum, and titanium alloys. And you can see that differences between mode 1 and mixed mode loading conditions depends of properties of the materials. I would like to remember that fatigue striation appears only at plastic region at crack tip. And in order to multi-physics computation of a couple deformation, diffusion, fracture, phase field problem, it is necessary to take into account and modeling of diffusion process, for instance, hydrogen or oxygen diffusion into the crack tip region. To this end, we employed oxygen energy dispersive method to analyze oxygen diffusion in the crack tip. We measured the oxygen concentration for blue line intact and red line damaged state of material for different cracks. For instance, that is a primary crack, isolated crack, and branching crack. You see that in all cases, differences between intact and damaged state of materials. You can see the peak of concentration of oxygen on the crack flanks. And last slide of my presentation is devoted. So I am nearly finished. Then the last presentation, last slide of my presentation is the comparison of oxygen distribution for fatigue at room temperature and creep fatigue interaction and creep at the creep fatigue interaction. And you can see that holding time at creep fatigue interaction intensificate diffusion process and accelerate damage processes. And concluding remarks. Phase field fracture approach is the most convenient for crack path analysis at different scales. The combined effect of elastic plastic properties and the granular structure of the material makes it possible to model the dominant fail chain mechanism and crack path in terms of phase field fracture. And last, a combined approach including numerical phase field modeling, experimental strain measurements with dig, cyclic loading, and careful analysis of fracture surface using electron microscopy method can provide exceptional capabilities in accessing structural integrity. Thank you very much for your attention.